B or not?
Down by the river? Eating government cheese?
So here we go. What I want you guys to look at here is the head nod. That's perfect. Bless you.
Nice.
Tangent of theta in terms of x's and y's is what over what?
Sine over.
In terms of
X.
y over x. Thank
Yeah,
you.
you just went over.
So what I want to do is remind you guys, we kind of talked a little bit about this before, where the graph of tangent comes from. So when we start tangent, we start by looking at our quadrantals at 0. 0, your y over x is 0 over 1. So that means that tangent of 0 is 0. The next easy tangent to find is at pi over 4. Because at 45 degrees, your tangent value was always 1. And then when you got up to pi over 2, what happened? It's undefined because it becomes 1 over 0. So when you're divided by 0 and you graph something, what occurs on the graph? The asymptote. So at pi over 2, we get an asymptote. Remember when we walked with tangents, we had the open circle at pi over 2, then we came back down to negative pi over 2. So at negative pi over 2, what also occurs? An asymptote. And again, halfway going across would be at negative pi over 4, which is also then at the tangent value of -1. Very good. So your tangent graphs are this. Tangent graphs have 3 easy points and 2 asymptotes. Yes, it's 0, 0, pi over 4 and 1, negative pi over 4 and negative 1. Except if they're shifted. You still have to worry about your A's and B's, but those are the 3 points you look at. Your parent function of a tangent graph, no matter what your A and B value is, will always, 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 always go through the origin. Your A's and your B's will help figure out what the scale is going to be as far as your period is concerned, as well as how high up that A value is, where the 1 goes. Now, in sines and cosines, we talked about the A value becoming the amplitude, how high up it goes. In tangent, it's not technically called an amplitude, but if you want to think of it in that manner, whatever your A is how far up it goes on the y-axis from the parent region. Does that make sense? Now, how far apart are my asymptotes? Pi. So the period of tangent is pi.
Always pi?
Always pi. The period of tangent, a basic tangent graph, is pi. What we do then is we work with it to figure out how it's shifted when we throw A's and B's in there. So all tangent graphs have very similar properties. A parent function tangent graph always goes through the origin. It has 2 asymptotes and a period. What the A's and B's stand for are the following. Oops, too fast. In tangent, you have your y equals a tangent b of x, where a is kind of like, we'll call that amplitude again. Think of it as how high up the 1 point, or how low down the 1 point will go on the axis to the parent function.
You said it always goes to the origin, and you has transfer goes where else?
2 other points that are going to be very, very, very easy to find. So far today, I've had to do 2 examples, and everybody was fine. It's that quick. Okay. The b value helps you to find the period. Your period for the tangent is going to be pi over the absolute value of b, and your asymptotes are going to occur at 1/2 your period. Okay. You're going to have 2 asymptotes. if you think about what we just did with the parent function, where you had it placed over at, we went through the origin. We had asymptotes at pi over 2 and negative pi over 2. Our period was pi. Half of it occurs on one side, the other half occurs on the other side. The two other points that you were asking about there, Zach, are always going to be between, it's going to be at the halfway point of 0 in your asymptote. In this case, it's pi over 4, positive and negative. And if these numbers change, you just take half of it to get those other points. It's always that. Always, always. Okay? Tangent is very simple to work with. The weird part of tangent comes in when you have to do your shifting, because you've got a lot more fractions. That's all. Other than that, it's pretty easy. Okay? Let me show you an example and how fast this actually is to do. Y equals 3/2 times the tangent of 4x. We start all these problems the same, label out everything you know, just makes your life a lot easier in the long run. I know that my A value is 3/2. My B value is 4. So then to find my period, it's going to be pi over 4. We okay with that?
Yeah.
All right.
Do we not have to write down the amplitude?
No, because technically tangent doesn't have an amplitude because it's infinite, because it's always increasing.
Oh, okay, sorry.
That A values can help us to find that point where it changes. That's all. If you want to call it the amplitude, I'm not going to know it yet, because I forget what it's called. Point of inflection. What's that? We're not there yet. We're at that's the asymptotes. Okay. Your asymptotes, since we're dealing with basically a non-shifted function here, this is going to work for when we do shifted functions, the same method. We're going to find the original asymptotes. Since you know your period is pi over 4, and it's going to go through the origin, your asymptotes can be placed at, well, what's half of pi over 4? Your asymptotes would be at plus or minus pi over 8. These are vertical asymptotes. So what's the equation of a vertical line? Yeah, so it's x equals plus or minus pi over 8. Zab, you looked at me like I'm crazy.
Oh, no.
So watch what happens. When you start tangents, you know that each one of these parent functions are always going to go through the origin. So put a dot there. Mark your asymptotes. Pi over 8. Negative pi over 8. And the reason we can say that our period is pi over 4 is, well, what's 1/8 plus 1/8? 1/4. So the distance between your asymptotes is 1/4. Pi over 4 if you want. Okay. That's how that works. Yes, ma'am? It is. It actually is graphed right now. This is the graph of period. The period is between here to here. Because 1/8 plus 1/8 is 2/8, which is 1/4.
Another the period was, oh yeah, the period was pi.
Yes. This generic form of tangent, x. No. You already wrote it. It's pi over 4. Because your period is found by pi over b. Your b value was pi. What's that? When we had this, our y equals tangent of x. The period was pi.
When we were doing
Well, we did just-
cosine, we used the 2 pi, and now we're using pi instead.
Yeah. Because tangent only is repeated every pi interval, as opposed to sine and cosine is repeated after 2 pi. You got to go completely around the circle to repeat. Tangent, you can't go all the way around because you have asymptotes on your verticals. That's why. All right. Now, to get your other 2 points, well, what's half of an 8?
16.
Pi over 16. What's half of negative 8? What's negative pi over 16? Your a value is 3/2, so just put 3/2 and negative 3/2. Tangent is always increasing going from left to right if your a value is positive. So it goes here, here, here. Connect your dots. You're done. That's a non-shifted tangent graph. Yes, ma'am.
So A is negative, but it's positive.
Yep. That's all it is. Just like how sines and cosines were negative, they went the other direction. Same thing with tangent. If the a value for tangent is negative, it would be decreasing, going from left to right. That's it. It's so quickly just chunked apart. 3 points, 2 asymptotes. What do you think H's and K's do?
Shift
them. Which way does the H go?
Vertical.
No.
To the X's, the H's.
Horizontal.
Oh, sorry. I deserve that.
I want you to accidentally throw a marker at someone, like someday, when you're like
I
going
want you to know you flinched.
when you're going to jokingly throw it and you just
It's gonna slip out of your hand one of these days.
Yeah. Again, H's and K's, the H's and K's do the exact same thing as they did with sines and cosines. It is so simple to see how it works. The generic formula is up on the board already. The only thing that's different is that if the A is negative, it's doing this. If A is positive, it's doing this. That's it. It is that blatantly straightforward. So when we list out our shift ones, so like we did yesterday, we're going to plot our original graphs, our parent functions, if you will. We're going to list out our ordered pairs, list our 2 asymptotes, and then we'll do all the shifted things via the ordered pairs first, and then graph it. It's pretty boring. Really can't screw you up too much with it. Boring can be accepted. Sounds scary. No. Dun, dun, dun. So let's look at this one. I don't have a k value, so let's do +2.
I don't have a K value, so let's give it a K value.
Why not? Why not just do one that has all of it thrown into it right off the bat? So we have -2 tangent times the quantity x plus pi over 4 plus 2. And just like always, start by labeling out what you know. Unless you're ready first. You know that your a value is negative. When you see that with tangent stuff, since it's a little bit different than sines and cosines, usually what I do, I notice it right away, and I make a note that it's going to do that. That way I know later on to plot it that way. Okay. What's your b value?
1,
So what's your period?
5.
Good. Where are your asymptotes?
Pi over 2.
Good. So we'll say it's at x equals plus or minus pi over 2 to start. And h value is?
Negative pi over 4.
Good. K. Plot it.
I thought you said Y. And I'm like, I don't know. That's what it said. You never asked why.
Again, notice that you have to move things to the left. Maybe over-exaggerate the left-hand side of your graph just so you have a little bit more space. These are moving up too, so if it's usually not that big of an issue with tangents. All you can do is just tack up a couple. So your parent function, where is the parent function going to go through?
The origin.
The origin, so you put a dot there to start. We know the parent functions go through the origin. We also know that your asymptotes for the parent function are placed at what?
Pi over 2 and negative pi.
So you plot it. What would be your other 2 points?
Pi over 4.
Yep. our 2 points that we can plot on the vertical axis will be at 2 and -2. Our A value is negative, so it's decreasing going from left to right. So, wait, what?
Why is it I thought, wouldn't it be 1 because that's the B value for that?
The B value helped us figure out the period.
Okay, so then,
The A value
Oh,
is where
the-
we're marking
oh,
on
okay.
the vertical. It's very similar to how the A value told you where to go up to and down to on your sines and cosines. In tangent, it's not technically called the amplitude because there's no limit to the verticalness. That word. To it, it's where it's changing directions. It's shifting itself through.
Okay.
A point of inflection, if you will.
thank you.
So just plot them. And dot it. Now the easy part. List them out. List out the points. Your original points were at let's see, negative pi over 4, positive 2, oops, 0, 0, pi over 4, negative 2. Now, when I write down my asymptotes, I want to make sure that I write down both of them separately, because you're going to have to move them horizontally. And it's not always going to wind up being plus minus, because they're not going to be centered around the origin when you have a horizontal shift. They're going to move. So just write them separately. You get negative pi over 2 and pi over 2.
Or you can mark down the asymptote?
Yes, please. Because what I'm saying here, Zach, is it's going to be a lot easier by listing out all the things that you have. Now you know all the things you have to move. Does that make sense? It kind of forces you to do that. Just like yesterday, I had you guys list out your 5 ordered pairs. So you had 5 ordered pairs to shift. 3 ordered pairs, 3 ordered pairs, 2 asymptotes, and a partridge.
There's a giant sheet of metal
On the cabinet. 5 blank stairs. 4
Empty desk.
empty desks. 3 6 points of inflection. 2 asymptotes and a tangent graph for me. So here we have an x minus pi over 4 and y plus 2. Remember, it's always easier to list out your ordered pairs prior to doing any of the work, because you're just adding fractions or subtracting them. So, negative 1/4 minus 1/4. Negative 1/2. So my ordered pair will be at negative pi over 2, and 2 plus 2 is very good.
Negative pi over 4.
Negative pi over 4, very good. You can add to 0.
Very proud of that skill.
Let's mess with that. What's the next one at? 0, 0. The parent function will always go through order, yes.
But the shift, is it just a...
Dumb luck. It's dumb luck. Now it's at 0 and 0.
Like right on the tree tester.
And then negative, then you have your
3
asymptotes.
pi over 4.
Good. When you take negative 1/2 and you subtract 1/4, you get negative 3 pi over 4. Okay? And the other one will be at,
Pi over 4, because the period is still pi, right?
yeah, because your period doesn't change. The asymptotes are just moving over, and they're staying the same width apart. Okay? Now, if you look at your graph, it just so happened, again, to be dumb luck, that we have already, most of these points already plotted on there. The one we don't have is the negative 3 pi over 4, I believe. Well, is negative 3 pi over 4 to the left or to the right of negative pi over 2? So we just put it in. Our other asymptote was at pi over 4. Tangent graphs are pretty cool if you have 2 different colors, because a lot of these points are going to overlap themselves. Or sometimes you might have an asymptote that goes through the y-axis. It's completely possible. All right, it's not a big deal. We know that our points are going to be now placed at 0, 0, negative pi over 4, and positive 2, negative pi over 2, and positive 4. Did I skip one? No, I did not. And now I just connect the dots. And again, it may look like absolute garbage because it's not scaled out absolutely perfect, but is it a visual representation of what it should look like? Yeah. And I know it's right because I got all the ordered pairs correct. And that's kind of the main idea here. If you can add your ordered pairs together, it's just a matter of making sure they kind of lined up on the graph and you'll be okay.
So do you want them to be different colors, or does it?
It doesn't matter. It really doesn't. I try to use 2 different colors when I'm doing tangent graphs because they overlap so much. Remember, it's completely possible and happens quite often that your graphs might intersect one another. But remember, the parent graph technically isn't there. It's just there to help you see the shift. That's all. So your graphs can overlap. They can share points. They can share. Well, I probably won't share an asymptote unless there's no horizontal shift, which is possible. Okay? And then the only other worst thing that can happen within the tangent is that your b value might be embedded within the parenthesis. And if it's embedded in the parenthesis, what do you have to do? Yeah, it technically is the distributive property. You just factor it out. And remember, if you're factoring it out, you got to make sure you take it out of the h value. So if this was just for example here, if this was a 2,
Pi over 8.
good, it'd be pi over 8 here because you're multiplying it by a half. Two examples good enough?
Yeah.
Usually it is.
How about there?
Make sure you list out your ordered pairs. Bottom three, you'll be fine. It's actually not these. This is 14.2 the homework comes out of, and it's 45 through 49 and 55, please. Okay? And you guys will be all right to go. I'll put them up on the board so books are heavy for most of you. Is it lonely?
No, it's not.
Didn't have your board.
Just kidding, it is probably good. I don't want
I've had lots of siblings.
Luckily, you haven't had power.
If my brothers could have met.
I feel like every teacher that ever had my phone, they read my last